Hello, wonderful people. Let's get started. All right, so by the end of this section, you should be able to graph quadratic functions by identifying the axis of symmetry and the vertex. Determine if a parabola has a maximum or a minimum, and graphing quadratic inequalities. So a little bit of everything here. So what you need to know, the standard form for a quadratic function is this: y equals ax squared plus bx plus c. So this is a 2-power function. So a 2-power function, if you remember a little bit of what I said in some of the previous lessons, I would say that a 2-power function has two potential solutions. That's not always the case, but that's just one way to think of it. So it also means that there are two directions. So like in some cases there is an up and then a down, or sometimes a down and then an up in these shapes. And that shape is a U-shaped curve that we call a parabola. These parabolas look, so I got some examples here. So it says, use your graphing calculator to sketch the following functions. So we don't really have graphing utensils readily available, but we do have some examples of other things that we could use, and I'm going to go ahead and switch over to that. So I graph these on Desmos. Just punch it into the graph. The only thing you may need to know about this is that the square button is on the keypad right up here. So if you push the keypad button, that will allow you to type in the square button. So we need to type in this case, I typed in the second one, and we have it graphed. Our crucial points here is this area on top of the parabola. So again, this is the second one. And we also have another crucial point here, here, and there. We'll talk about what these crucial points are in this lesson. So there's the first one. This is not the one we graphed. This is the one that we did not graph. This is the one that is on the, that I just showed you. But anyway, they're both graphed. And the thing they're trying to point out to you in this case is that if A is positive, your parabola will open up. So if it's positive, it's like a smile. If it's negative, it will open down like a frown. These graphs also have vertexes very similar to absolute value functions. And these absolute value functions, kind of like them, there's a part where they turn around. Now, in this case here, we have a point down here that we consider to be the turning point. And that is what we would call a minimum. So as we go down along the curve, we reach a part along the bottom that we cannot go any lower. That's the lowest it can go, but it does go up in both directions forever. So there should be little arrows on these lines. And in this case here, we have this one that opens down. We go up, we reach a maximum, and then we have to go back down the other way. So this is kind of like climbing a mountain. If somebody were to climb a mountain and reach the very peak, that would be the highest point, and they would not be able to go any higher. So to get these graphed, you will need to know a few things. There is a vertical line that puts it into two parts. So it's kind of like, again, other functions we've worked with, that there is something called the axis of symmetry. So symmetry is something that you've seen before. So like this triangle here, if I drew it really well, is symmetrical. Because if I were to draw a line down the middle, it would be the same on both sides. But if I were to, say, draw a teacup, and because of this handle in this case here, it would not be symmetrical if I were to reflect it along this axis here because of that handle. Now, if you were to turn the teacup, you could probably get it to be symmetrical, but that, I'm just letting you know that it's symmetrical, again, means the same on both sides. So the formula for this is going to be negative b over 2a, and you are going to use the same formula that you saw on the previous slide. So we're going to use that formula here. Oopsie. This formula will have these points plugged into this part here. So whatever your b value is, your middle term, assuming it's an order, is going to be on top, made opposite, and then divided by double the a value, or the first term's value for the coefficient. And I've already mentioned this part here, the vertex. So that vertex is the turning point. Minimum and maximum, so minimum again goes down and cannot go any lower and then comes back up, whereas a maximum will go up, reach a height, and then come back down. And these are the parts of the graph that we need to label them for our next exercise. So where can you find some parabolic examples in real life? Now, parabolas are actually fairly common in real life, actually. The two best examples that I can think of would be if you were to suspend a chain from any 2 points, and in this case, it would be flexible and have enough weight to hold itself down. You know, if you were to spread your arms or move them closer together, the chain points, it would always be equal on both sides, and it would always form a parabola. So that is an example. Again, if we were to go down this chain, we would reach a minimum and then have to come back up. Now, unlike graphed parabolas and functions, this one doesn't go on and on forever. But again, you can see that we go down and we reach a minimum and then we go back up. Another example of parabolic, a parabolic example is movement of projectile motion. So when you throw something, when something is freely moving through the air, or going through the atmosphere, whatever, actually anywhere, even orbits in planets are defined in some parts by parabolic motion. Well, they're just basically falling in one direction very fast. But anyway, if you were to throw something, it also reaches a maximum height. Once it kind of uses up the energy from your arm, it will start going down towards the ground, and it will almost follow a mirror path. And this is, again, ignoring air resistance. So that's an example of where you find, and there's actually a lot more examples too, but these are the ones that I think people would be most familiar with. So now we got to determine if any of these functions have a minimum, maximum, and then find the axis of symmetry and the vertex. So we are going to need our formulas, and we are going to need the negative b over 2a function, formula ourselves. So let's go ahead and work on this first example here. I have f of x equals 4x squared. All right, so it's missing a couple of the things. It is missing a b value. It is also missing a c value. Now, if it's missing, in this case, it's completely gone. So we assume that it's going to be 0. So if I'm looking for a b value, I have no numbers that are followed by just plain x, or x to the 1 power. So in this case here, it's going to be 0, plugging it in here. Now it's not going to be negative 0 because there is no such thing as negative 0. Now I gotta double the a value. So the a value is the number paired with the x square. So in this case here, 2 times 4. Not that that really matters, because 0 divided by any number is always going to be 0. And that's our axis of symmetry. To find the vertex, what we need to do is we need to plug in the axis of symmetry into our original equation. So I'm going to go ahead and look for the vertex in this case. So I'm going to plug in 4 times our number here. So in this case, it was 0. In for x. So instead of 4x squared, I get 4 times 0 squared. And if we square 0, we get 0. 0 times 0 is 0. And 4 times 0 is still 0. So multiplicative property of 0 says that 0 times anything is always going to be 0. So in this case, our vertex is going to be 0. And to find out whether it has a minimum or a maximum, all we have to do is look at the a value. In this case, my a value is positive. So remember, positive is like a smile. So it's going to open upwards. If our function opens upwards, the parabola, it's like a smile. And this is a little bit backwards from what you might think. You might be thinking, ooh, if it's a positive, it must be a maximum, because, you know, maximum, no. That's not it at all. That's not it at all. If it opens upwards, that means there is a minimum. All right, because it goes up in both directions in the positive direction. So there's a low, but there is no upper maximum. So that's how you would do these. Let's go ahead and work on this next one. Okay, so let's go ahead and follow. Let's do this one in order the way we should have done the other one. So first off, let's find out whether it has a minimum or a maximum. For this one here, my minimum is going to be, well, actually, hold on. If it's going to open down, it's going to open down because this is a negative, right? So we have a negative number here. So that negative number would indicate that it's going to look like a frowny face. And in this case, that would mean that it has a maximum. Now we're going to try to find the axis of symmetry by using our formula here. So negative b, which again, b is the one that is always paired with the regular x number. So in this case, it is 6, but it's also going to be made negative or opposite. If your b value so turns out to be negative to begin with, like this one, then you will have to change it to a positive. Let's go ahead and plug in 2a. So that the 2 is always going to be there. But in this case, my a value is -1. So -6 divided by -2. So negative divided by negative is going to be positive, and 6 divided by 2 is 3. So that tells me that my axis of symmetry is at x equals 3. So that would be a straight line up and down at the 3 mark. Now to find the vertex, we know that on the axis of symmetry, remember, that's the part where it's going to be symmetrical. So it's going to be the same on both sides. Since this one's opening down, it's probably going to look something like this. Let's plug that into our vertex. So grab our original function, and I'm going to take out the x and replace them, in this case, with 3. Now I'm going to have to kind of do a little bit of work here. 3 squared, so follow your order of operations when you evaluate these. So if you follow PEMDAS, parentheses, now in this case we don't count these parentheses because they are not grouping symbols, but we do have an exponent and a multiply by -1. Remember, if you see a -1 in front of a group like that, it means you are multiplying by -1. So in this case here, we have to do the exponent first. So this is 3 times 3, which is 9, but it's going to be 9 times a -1, so that'd be -9, plus 18. So 6 times 3 is 18, so I'm going to add these together, or 18 minus 9 is going to be 9. Now, to get the vertex in this case, actually, I also should have written it as an ordered pair. So every ordered pair has an x value and a y value. In this case, the x value is taken straight from your axis of symmetry. So this 3 is the same 3 we got here. And I said it should be 9, but I don't know why I didn't put 9 in there. And this 9 is the one we got after plugging it in for the x. Okay. So now we are done with that one. Let's go ahead and move on to this one here. So we also have a minimum in this case. Now, if you're completely lost, you could probably also use the graphing tool that we used earlier to find this out. But again, using what we know, let's go ahead and use the information. And we know that in this case, the number that is with x squared, the a value, is negative. Negative means that it opens downward. And again, down like a frown. And if we follow that, it would be like a ball being thrown. There is a maximum height. Oops, maximum. It'd be like a maximum height. It goes up, comes back down. But in that case, you might be interested in knowing how high that ball went at its maximum peak. All right, so let's go ahead and plug in to our formula here to see what we can get for the axis of symmetry. So axis of symmetry is going to be these numbers plugged in. Now in this case, I have no b value. And again, don't get confused, because I know one of the things that people always do is look at the order of the numbers and not the term of the number. So in this case, I have no x number, just regular plain old x number, not there. So in this case, it's going to be 0. And if I were to multiply it times our a value here, which is -2, so plug that in, doesn't matter what we get. 0 divided by anything is always going to be 0. So this means that we have an axis of symmetry that is directly in the middle of our graph. And just like the last one, let's go ahead and plug it in. And I'm going to take out the x and replace it with a parenthesis. And we are going to plug in the number we got for the axis of symmetry, which is in this case is 0. And 0 squared is going to be, well, 0. And -2 times 0 is still going to be 0, and 0 plus 7. So in this case here, we just end up with 7. Now again, that's going to be our y value for that. And the x value for our vertex is going to be the axis of symmetry's number, which in this case, again, we got as 0. All right, so we're done with that one. Let's move on to number 4. So with number 4, we have all 3 terms. So this is basically a full quadratic formula. We have an a, we have a b, and a c value. So again, sticking with what we know, this is a positive x squared number. So positive, again, looks like a smile. So we just draw a little one just to see if we can get an idea from it. So there's our smile. And we go down, reach a minimum, and then go back up. So there is a bottom of that. Now you can think of that also like a hill, or I'm sorry, a valley. You know, if you throw a rubber ball into a valley, it's going to roll to the bottom as far as it can go. And once it gets to the bottom, it can't go any lower, and it's not going to come back up on its own anyway. So let's go ahead and plug this into our formula here for the axis of symmetry. So in this case, I get -8, because there is a negative in the formula, but there is also a negative that the 8 brought with himself. And then 2 times a, which in this case, if there is no number or no coefficient in front of the term that you're looking at, so in this case, it's the x squared term, we don't have a number in front of there, it's going to be 1. Because again, there is a hidden 1 right here. Opposite of -8. So opposite of -8 is going to be +8, or again, they will cancel each other out. So we get 8/2. Divide it, if you get a fraction, divide it or reduce it, which in this case we can divide it. So in this case, our axis of symmetry is at 4. So we're going to have a line like this, and it's opening upwards. So it's probably going to look something like this if I were to graph it on a graph. Now let's go ahead and plug that 4 back into our formula. So x squared, so take out the x, minus 8x, take out the x, plus 9. Now drop our 4 in there like that. 4 square is 16. Minus 8 times 4 is 32. Plus 9. And let's see what we get there. Okay, so that'd be negative 16 plus 9. And in this case, we get negative 7. But we need to write that down in an ordered pair form. So negative 7 is our y value. But again, our x value for the ordered pair is going to be the value we got for the axis of symmetry. And we're done with that. So moving on. Now what you need to know for graphing absolute value, not absolute value, what am I talking about? Graphing okay, just read it. Find the axis of symmetry and then the vertex. So that's what we did in the previous exercise. Place the vertex into the table so that the vertex is in the middle row. Pick a few numbers going up and a few numbers going down. Get all those numbers solved for and plot those onto the graph and do your best to connect the dots. So let's go ahead and plug some of these in there. So first thing we got to do is find the vertex, and that is going to be our negative b over 2a formula. So let me go ahead and go back over to get that. And we're going to need these for all of these. So let's go ahead and plug in negative b over 2a. So negative b, now in this case we have no b value. And it doesn't matter what our a value is going to be, because if b is 0, 0 divided by any number, in this case 0 divided by negative 6 is still going to be 0. So I'm going to label my axis of symmetry like this. AOS, it's just abbreviated for axis of symmetry. Now we need to do our best to graph it with 0 in the middle. So I'm going to go ahead and put 0 here and pick a few numbers going down. And a few numbers going up. So now we have to do our best to plug these numbers in and then evaluate for them. So 0 times, well, plug it in here, 0 times 0 is going to be 0. That takes care of the exponent. 0 times negative 3 is going to be 0. So that means our vertex is going to be right here. And since it's a negative, that means that our graph is going to go downwards. So it's going to likely look something like this. Now let's go ahead and continue plugging these in. So negative 1. Now if you need to, I would highly recommend that you write these out. So negative 3 times negative 1 squared. Negative 3 times, let's see, negative 1 times negative 1 is going to be positive 1. And positive 1 times negative 3 is going to be negative 3. Now that means that we have an ordered pair here at negative 3. And let's see, we have another one at 2. So I'm going to plug in negative 2. So I'm going to go ahead and erase this. Negative 2. And if I square negative 2, I get 4. Positive 4, because remember, a negative times a negative makes positive. So that's why I have positive 4. And negative 3 times 4 is negative 12. Now at this point, our graph is off of the, well, it's off the chart, so our graph only goes up to 8 but that's okay. We're going to continue it anyway. Let's go ahead and put -3 in there. So -3, and if I were to square -3, so that's -3 times -3, that would be 9, or +9. And +9 times -3 is -27. Okay, and here I have 1. So continue the graph in both directions. And if it's symmetrical, just like the other functions that we graphed, if they're symmetrical, they should have the same numbers on both sides of the chart, of the table. So plug in 1, and 1 square is 1, and -3 times 1 is -3. Let's go ahead and put 2 in there and see what happens. So put 2. So 2 square is 4, and 4 times -3 is going to be -12. And let's go ahead and do the last one, and that will be 3. And 3 square is 9, and 9 times -3 is -27. And from here, we should have enough information to graph our line, parabola. And that's gonna go through, so let's try our best to go through these areas. So again, it starts from 0, 0. Actually, you know what, for you, you probably should plot these points as closely as you can. So we have 0, 0, -1, -3, and -2, -12. So that's going to be way down here. Our line is going to be extremely narrow, our parabola. And that's about the best I can get it with this. And it says state the domain and range as the last thing we do. Now, this parabola is very, very narrow, but it still goes on and on forever in both directions. So if it still goes on and on forever in both directions, that would mean that it is an all real numbers. Even if I pick a value of x being 10,000, I would still square 10,000 and then times it by -3, and I would still get a number out of my function that I could pick anything and put it in there. Now for the range, we're looking at this column of green numbers, and in this column of green numbers, you notice that the numbers start from -27, go up, -12, -3, and it gets to 0, and then it goes back down. So we cannot pick any numbers higher than 0. So we can only pick y values that are less than 0. Now in this case, we can pick 0 itself. So there will be an or equal to in this case. All right, and we are finished graphing that one. So let's move on to the next one. Let's use our formula, the -b/2a, and I'm gonna go ahead and just do the same thing I did on this one here and grab our b value, which again, a, b, c terms. And again, you gotta check if it's in order, because sometimes they might pull a switcheroo on you and mix these numbers up so that they're not in the correct order. And you got to make sure it's in the correct order, which is descending order. So highest power to lowest power. So 2 power, 1 power, 0 power terms. All right, so -6. So we make it opposite. So again, there's going to be 2 negatives. So opposite of -6 over 2a, which in this case 2 is 2 stays, and my a value is 1. Even though there's no number in front of there, it's going to be 1. So these negatives will cancel each other out. So I get opposite of -6, or take away the negative. If you take away a negative, it becomes positive. So that's how I got positive 6. 2 times 1 is 2, and in this case, I got my axis of symmetry. So I know that in this case, my axis of symmetry will be here at 3. And I'll go ahead and label this one along the top as axis of symmetry, or AOS. Now I'm going to put my axis of symmetry in the middle of my table, and I will pick numbers that are less and some that are greater. So I just pick the numbers going up and down. And now we're going to have to put these numbers that we have for our x into this formula and evaluate it so that we get the numbers that we're looking for. So in this case here, I am going to rewrite this and put it into here. So x squared, oh, looks like I'm using green. I'll just stick with green for this one here. So x squared okay, so x squared minus 6x plus 11. Now I'm going to go ahead and drop in my numbers, so 0 and 0, and evaluate it. Okay, this one's going to be an easy one because 0 squared is 0, and negative 6 times 0, well, anything times 0 is going to be 0. So we're going to get 11 for my first number here, and go ahead and take these out. And you don't need to erase these. I just don't have any room to write these problems. And if you look at your paper, it doesn't really give you much space either on the work. So I would recommend doing this on a separate sheet of paper. You don't really need to turn in that paper, I guess. But it'll be there to help you plot the points. All right, so 1 squared is going to be 1. Negative 6 times 1 is going to be negative 6 plus 11. So let's go ahead and work this out. So this is 1 plus 11, which is 12, and 12 minus 6 is going to be 6. So the next number in this column is going to be 6. All right, let's go ahead and, again, you don't need to erase this. You would just write that whole thing again. But the other thing too is, again, I'm using a mouse to write all these. So writing would take a little bit longer, and it's a bit more tiresome for me to write most of this. So I'm going to go ahead and put this number in there. So we're going to put 2 in there and evaluate it. So 2 squared is 4. Negative 6 times 2 is negative 12, and the 11 stays the same. And I'm going to add my positive numbers together. So 11 plus 4 is 15, and 15 minus 12 is 3. And put in the next number, which in this case is 3. 3 squared is 9. Negative 6 times 3 in this case is going to be negative 18, plus 11 stays the same. And I'm going to add my positive numbers together. So 11 plus 9 is 20. And 20 minus 18 is going to be 2. And we're going to keep going. In this case here, I'm going to put in 4. So put in 4 into your function and evaluate it. So 4 squared is going to be 16 minus negative 6 times 4 is negative 32 plus 11. And this would be negative 16 plus 11, which is going to be 3. Let's go ahead and put 5 in there. So 5 is going to be replacing in for x. 5 squared is, 5 times 5 is 25, minus 30 plus 11, because 6 times 5 is 30, and it's going to be minus. So 25 minus 30 is going to be negative 5. Negative 5 plus 1. I'm sorry, wait, no. Okay, working that out. Anyway, all right, last one. Plug in 6. Oopsie. Anyway, 6 squared is 36, and this is also 36, so we get 36 minus 36, which would be 0 plus 11, which basically just gives us 11. Now from here, we should have enough spots on our graph to to finish the graph. So let's go ahead and plot these out. So 0, 11. Okay, I can't graph that one because it would go off the chart. 1, 6. So 1, 6 is going to be there. 2, 3. So over 2 up 3. And 3, 2. So over 3 up 2. 4, 3. So over 4 up 3. 5, 6. So over 5 up 6. And we also have another 11, so that's going to go off the chart. Do our best to connect these lines. And again, these are going to be curved lines, so you got to do your best to draw the lines as is. There we go. Now we are done with that parabola. And make sure your line here is curved, okay? Because whenever I see these graphed, a lot of times it'll be like connecting the dots, and you know, like those old coloring books where they have you connect the dots. If you give them to younger kids that can't really see the picture before, they always make straight lines to each dot, and it kind of makes the whole thing look a little sharp, edgy or whatever, right? But you got to make it kind of smooth, so it's got to be a curve from this to that and on through. So domain, and as far as I know, nearly all parabolas have a domain of all real numbers. Now, because it's a function, it cannot repeat any x values, and there are no holes or gaps in any functions that I'm aware of. I don't know, I've been doing this for 10 years, and sometimes I'll learn something new. But anyway, in this case here, my range would be, we have a minimum, right? So we have a minimum value. So our minimum value, if we look at our y-axis, it's at 2. So any y value that is greater than 2. So since our graph is opening up from 2, so y value is greater than 2. And in this case, 2 is included on our table. And that's why we look for the vertex, because whether it's a minimum or a maximum, your vertex always includes that, again, highest or lowest number of your range. So that's why we got to look at the table. So in this case, any y value greater than 2. So if I want to pick, say, y of 6, I can, or yeah, y of 6, I can get 2 parts of the graph intersecting my line like that. But I cannot pick anything below 2 because this table does not let me go lower than 2. So I can't plug in anything in x to my original function that would give me a value less than or equal to 2. Or I can only get numbers less than or equal to 2, but I can't get numbers less than 2. Okay. Graph each function, state the domain, and range. All right, so to graph this, let's do the same thing. Get our negative b over 2a. And we need to have the, it's a division thingy. Yeah. All right, so let's plug that in here. So grab our -8. But it's going to have a second negative because there is a negative on the outside of that formula. So I end up with two negatives, one the b brought and the other one the 8 brought. So I end up with two of them. Now 2 times a, so 2 times, in this case my a value is 2. That's this number right here. So 2 times 2 in this case would be 4. And my top number is going to be opposite of -8, which opposite of -8 is +8. And my axis of symmetry is going to be at 2. So again, I'm going to label my axis of symmetry. And actually, unlike the other functions, the axis of symmetry is part of the solution. You have to label that axis of symmetry. So we know that 2 is the middle number, so 2, 1, 0, -1. And pick some numbers above that. And let's plug it in. So 2x squared minus 8x plus 6. And we're going to plug these numbers in there. So I'm going to start with -1. -1 squared, so you got to square these first before you multiply them. Again, exponents before multiplication. That's what PEMDAS tells you to do. -1 times -1 is +1. +1 times 2 is 2. And that takes care of our first term. And next term will be negative times negative, so this will become +8 and +6. So 2 plus 8 plus 6, and that will give us an output of 16. Okay, 16. All right, there we go. Let's go ahead and plug in 0 now. Zero, 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 zero. Where am I? All right, here we go. So 0 squared is going to be 0. 0 times 2 is 0. 0 minus 8 times 0, which is also going to be 0. And identity property that tells you that adding 0 does not change anything. So in this case, I end up with 6 again. All right, let's go ahead and move on to the next number. In this case, we have 1. So 1 in there. So square 1. So 1 squared is going to be 1. And then 1 times 2 is 2. So first number is 2. -8 is going to be, well, -8 times 1 is -8 plus 6. And in this case here, we can add our positive numbers together. So that's 2 and 6 is 8. And 8 minus 8 is 0. Plug in 2. So let's go ahead and plug in number 2. And evaluate the function at 2. So 2 squared is going to be 4, and 4 times 2 is going to be 8. -8 times 2, so -8 times 2 is going to be -16 plus 6. And put all those together and you get -2. All right, and then moving on to the next one. Let's put in 3. for x. And we got to do it to two of these two, so that kind of makes it a little tricky. So 3 squared is 9, and double 9, you get 18. Minus, in this case here, 8. 8 times 3 is 24. Plus 6. Now again, if you have a pretty good calculator or you know how to do this, you can do it in order. But again, I like to add my positive or my like numbers first. So if they're both positive, I add them together. So in this case here, 18 plus 6 is 24, and 24 minus 24 is going to be 0. And since we placed our vertex in the middle, that's exactly what we would have expected. We would have expected that number to be in the bottom. So since it's on the bottom, that means that it's going to kind of reflect up this way. Put 4 in there now, so we got to put 4 in for x. Oh, and erase this here, so that should give us our y values. And remember, f of x just means y. So 4 square is, what is 4 square? 4 square is 16. 16 times 2 is 32 minus, and then 8 times 4 is going to be 32. And if it doesn't seem right, let's plug it in and see if it makes sense. So again, it should be symmetrical here. So -2, and then 0 is the next number over in both directions, and 6 is over the next number from 0 in both directions. So that makes sense. And again, it should be symmetrical anyhow you do it, like that. I'm going to take this and move it over here. Maybe put it right there so it's a little bit easier to spot. And I'm going to move that number over. Anyway, let's go ahead and graph our parabola. Okay, so I can't mark 16, but I can mark it at 0, 6. Over 1, 0, 2, -2, 3, 0, 4, 6, so over 4, up 6. And again, it should be symmetrical, which is why it's called the axis of symmetry. Do our best to connect these dots. I'm lucky I have a tool that helps me do this. And there's our parabola. And again, no matter how narrow they are, they always go in both directions. So let's put all reals. My pinky is just dumb on my left hand. Just for whatever reason, I can never teach it to do anything. So I always have a hard time typing in that, because when you type in the word real, all the numbers are hit by all the letters are hit by your pinky, and my pinky just doesn't work as good as it used to. Anyway, range. So range starting from the bottom, working our way up. The lowest number we run into is going to be -2. Now we need to have y values greater than -2. And I know sometimes this can be a little tricky. I think I've said this in a previous lesson. Please, please, please try your best to get the domain and range correctly. I'm a little bit more lenient on this because I know sometimes, especially when you have disjointed ranges, it can be tricky. Or if you have, holes or gaps in your range, yeah, it is a bit tricky. But again, please try it out. I'm not going to mark you wrong if it looks like, you put a good effort into it. So it can be a little bit intimidating. Try it in both directions. Now, if I put it like this, is it going to work? Because no, it says y is less than -2. But no, the graph is opening upwards, so we need numbers greater than -2. So that's kind of a quick check that you can do, is something like that. And again, since -2 is included, we have to identify that it is equal to that number. It's equal to -2. I'm going to make this a little bit darker. I'm not I think I'm going to start graphing it a little bit darker in the future. Okay, now number 8. So let's go ahead and find our axis of symmetry. So to find the axis of symmetry, now this one is missing one of the terms. It is missing the middle term, the x number. And when it is missing that number, that means that it does not, it would be 0. Okay, when it's completely missing, when the term is completely missing, it's 0. This is different than seeing, like in this case here, nothing in front of that x. In that case, it's 1. So I know sometimes that's a little bit tricky that people say, wait a minute, sometimes it's 1, sometimes it's 0. But think of it this way. If I told you there was at least one dodo bird, that means it exists. But if there are absolutely no dodo birds, then that means they are all gone. There are 0 of them. So if I have any, if there's any variable, that's a 1. If there's nothing, it's 0. So let's go ahead and plug that in. There is no b value. If there is no b value, that means my top number is going to be 0, and it doesn't matter what I do to it. 0 divided by 0 is always going to be 0, which makes picking numbers for this pretty easy. Now I'm going to go ahead and get my formula. So negative and I only have one number to plug in, so let's go ahead and start plugging things in now. -3 times -3 is +9. But this negative on the outside is not affected by this square. So this negative comes down. This one is gone, but it jumps onto the 9 once it gets out of the parentheses. And again, if you feel like you're having any trouble with this, just check your work with Desmos, okay? Just plug it in, go to Desmos, type in that equation as close as you can. In fact, most cases you can graph exactly what you need. So in this case here, we get -4 as this number here. And let's go ahead and do the next one for -2 and evaluate the function at -2. So -2 squared is going to be 4. And it's going to be negative again because this negative is the one that is affecting it. So I'm going to try to keep the colors the same so you can kind of see where the negative came from. So the 4 became positive, but this negative just jumped on. And now you have a negative number. So that's -4 plus 5, which in this case would be 1. All right, next number. Let's go ahead and plug in -1. So -1 squared is going to be +1, but again, the negative on the outside, it's not going to let it be, so we get +4. And it's just easiest for me to erase these and use the same one, so I'm not writing the same ones over and over again. 0 squared is -0 plus 5, so that would be 5. Oopsie, went a little bit out of the line that time, so 5, like that. And then 1, so let me go ahead and put 1 here. 1, 1, there you go. 1 squared is going to be, well, +1 anyway. And it's still going to be turned negative, so it's going to be -1 plus 5, which is going to be 4. And for this one here, we have 2, which 2 square is 4, which is now -4 plus 5, which is 1. And -4. And again, if you're doing this right, you should be able to just mimic your table on that side. But I would suggest you play it safe and don't do that. Solve all of them. In case something happens, like you forgot to put a negative in, and if you get any shape other than a parabola, then you probably did something wrong. So anyway, axis of symmetry is right here. And again, I'm going to label that AOS. And we're going to plot these points. So -3, -4, -2, 1, And negative 1, 4. Oh, wait, no. Negative 2, negative 1 would be like right here. And negative 1, 4. 4 is way up here. Weird. Or did I do? Oh, okay. I know. Wait, okay. I see what I think I might have. I put this in the wrong spot here. So this should be negative 2 up 1. Okay. Now that makes a lot more sense. Okay, because these curves kind of always follow the same pattern. So if you ever do something like that and you notice something doesn't quite match, check it. Over 1 up 4, over 2 up 1, and over 3 down 4. So now I have, oopsie, let me go ahead and get this as close as I can. Now this curve that I have is not the best tool. It's a little bit off. It should do me okay for what I need to do today, but you get the idea. So there we go. Now we have our graph. So domain, this one should be no, come on. Yeah, I injured my pinky like 10 years ago, and I don't know, there must be like some damage in there or something, but I honestly just can't control my pinky sometimes. All right, range. So range is any y value less than 5. But again, 5 is included into the table. So we make sure that we show that it's included by putting the or equal to below it. And we'll go ahead and go over this. We'll make this one the last slide, and then we'll continue this later. Okay. Looks like we're going to have some piecewise functions for this one here. Now, just to make things go a little bit faster, well, no, I really shouldn't. Let's go ahead and just continue doing the things the way we've always done it. So negative b, which in this case, my b is this number here. So negative b is 1 over 2 times half, because my a value in this case is half. Now that would actually be negative half here. So I'm going to have to squeeze that negative sign somewhere in there. All right, so 1 stays and 2 times half. So if you have 2 halves of a dollar, 2 halves of a dollar, you would have 1. In this case, we have 1 over 1. Well, actually, in this case, it would be negative 1. So our axis of symmetry would be at negative 1. So go ahead and I'm going to put a dashed line right here. Label it axis of symmetry, negative 1, and pick some values below that. So negative 2, negative 3, negative 4, 0, 1, 2. Okay, now we got to start evaluating this at all of the numbers. Let me show you another way we can do this. Let's go back to that Desmos, and I'm going to type it in. Now I'm only doing this one because it's a bit of a tougher one. So negative 1/2 x squared, and I'm going to need to minus x. And you notice the graph is kind of shifting every time I erase or move something. So we end up with a graph that looks like this. So our vertex is here at negative 1 and half. At 2, it's there. And if I want to make a third line, I can put x equals -3. And I get my third point. So in this case here, since we're going down to -4, we could also put another line at x equals -4. X equals -4. And I already have one. If I needed one here, I could put each of these, and I just have to look at where they intersect. And from here, I have all the numbers I need. So at -4, it's at -4. Next one is -3, -1.5, and -2.0. Now again, you might be tempted to do this every time, but please, please, please fill out your table the best you can. I'm only doing it this way because it's going to take a while, and there's a fraction in there, and I'm just going to make it go a little bit easier. So let me get those numbers looking at the other screen. And then graph it as usual. So -4, -4. -3 and -1.5. -2, 0. -1 up 0.5. And we also have a vertical compression going on here. So remember, vertical compression is like you're squishing it like it's in a press machine. If you ever watch that YouTube channel, it's pretty good. You get to watch things getting crushed. And in this case, we're crushing a parabola. And again, too, this is not the best tool for the job, but it seems to work out fine enough. And try our best to go through those. Now, again, some of those are not right in the middle. I made them really short marks just so that way we could get them to fit them in there. All right, now I wanted to spend a little bit more time on this one, which is why I decided to save this one here, so that we had a little bit more time on that one. And we just need our highest number, in this case, y is less than 0.5, oops, 0.5. No, in that case, it's actually the wrong way. So again, don't be afraid to judge your work in this case here. No, 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 no. Did I have it right before? So if I want to check it, I'm just going to put 1 in there, or maybe 2. So if I put y is 2, that would be true. So I don't want it to be true if it's facing in the opposite direction. Yeah, there you go. All right, I just had a brain fart right there. So let's go ahead and do this one here. So we have a break. So similar to the piecewise functions that we've already covered, there is a break at -4. Now in this case, this is not my axis of symmetry. I'm just putting this line here to remind me to stop drawing the line once I get to that point. Now I'm going to go ahead and graph this one here. So yesterday I made excellent breakfast. So start with breakfast. 5 here. And I'm going to go up 2/1. And do my best to go this way here. And I end up with a line that looks something like this. So, okay, 5, up 2/1, up 2/1, up 2/1. And actually, I need to do my best to draw a line that matches over this one here. And I'm going to have to delete this line up because I don't want anything on that side of the line. That's there to remind me again to stop drawing the graph at that point. And I'm going to need to graph this. So grab the b value, which is -3, over 2a, which my a value is 1. So this means that my vertex is going to be at -3/2. And that would mean that it's at -1.5. So if I were to try to graph this, now this is my actual axis of symmetry. And I'm gonna just, it doesn't give me a table, so if you need a table, you can work it out. But again, most of the time, if your A value is 1, you're gonna have the same kind of function. It's gonna be the same steps. If you can imagine, they're like steps. But this one doesn't give me a table, so if you want to, you can draw tables and fill that out. But I'm gonna need to find the vertex by plugging negative 1.5 into the function and evaluate it there. So in this case, 3 times 1.5. And that's all it gives me. So 1.5 times 1.5 is going to be 2.25 plus, and 3 times 1.5, and that would be 4.5. 4.5. Oh, it's supposed to be negative. Sorry, that would mean that this would be a minus as well. So minus 2.25, and I would end up with the vertex being at negative 1.5. So that should be my vertex there. So it's going to look like this, and in this case, again, I'm just going to just draw a parabola that we just have kind of going, the normal everyday looking thing. But this one's going to end right there, okay? So again, that line is there to remind me that this is where it ends. So it's going to look something like that. We only have one more thing to do for the graph, and that is to use open or hollow circles to cap them off with. So for x values less than -4, we do not include them. So open circle here. For the parabola, the second part, so again, for all the stuff on this side, we want x's that are greater than -4. So I don't think we really need this line either. It's just sort of distracting, just to help us graph it, really. And again, for this one here, without the table, I'm not concerned too much with the exact values, as long as it looks like a parabola. All right, as long as it just looks like a parabola, I'm not going to break out my magnifying glass and make sure you go through all the points exactly like you need to. And it's only because this one doesn't have a table. And this one here will be capped off with a filled circle, because it does have the or equal to. Domain is all reals, because again, there are no gaps in this. And the range is going to be, well, there's a huge break in it, right? When I'm going up, 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 I run into a hole, and then there's a gap to the lowest part of the vertex of the parabola. So we're going to have a disjointed graph, so that would be y values less than -3, but there would be no or equal to, because it's capped off with an open circle. So I cannot choose that. And then you would have the union, which in this case, I'm just going to use capital U. You can also use a comma. I think I've been using that in the past. But union basically means like the word and. Y values greater than negative no, hold on a minute. Did I do that right? 2.25 minus 4.5. And I think it's supposed to be 2.25. 2.25. So that would actually mean that the vertex would move over here. And that would mean that I'd have to move this whole thing over down this way. A little bit more down. that wouldn't change too many things. Yeah, okay. Like I said, I'm not worried too much about this one here. But just to fill things out here. And that one is kind of confusing. And like I said, try your best on some of these. It will be a challenge to anybody. Okay. See, even I kind of I miss things every now and then. So nobody's perfect. And anyway, that's it for this one here. So it's a bit of a longer lesson. As always, you know, whenever you're done, I'll see you tomorrow. Bye-bye now.